So in question number 19, a thin uniform rod of mass m and length L is kept on a smooth horizontal surface. 2 point masses of mass m and 3m moving horizontally and perpendicular to the rod collide and stick to the rod after collision as shown in column 2. Point O represents the center of mass of rod. If VO, VA represent the velocity immediately after the collision of O and A respectively, then match the entries in column 1 with the entries in column 2. So first of all, we have to check the entry A and B of column 1. So in order to do this, we have to analyze the situations of column 2. So if I analyze this situation, then it is given that the M is striking at a distance of L by 4 and 3M is striking at a distance of L by 12. So the center of mass of the combined system will be at this position only. So center of mass in that case is here only of the new system. So if I find out the velocity of point O in this situation, that is the velocity of center of mass, so it comes out to be 3mv minus mv divided by 4m plus capital M. So this is not equal to 0. In the second case, if I find out the center of mass of the combined system is at this position only, so the velocity of the center of mass or point O is non-zero in this case. So in the third case, if I see the new center of mass of the combined system has shifted to this position, so the velocity of point O is non-zero in this case. In the entry S, if I check, the momentum is 0, but if I check the new position of the center of mass of the combined system, then it has shifted to this position. So we can say that in that situation, the velocity of point O is non-zero. In the last, if I see the momentum is 0 as well as the position of center of mass is this, so the velocity of point O is 0. So the correct matching for entry A is T, and for entry B it is P, Q, R and S. Now we have to check the entry C and D of column 1. In entry C and D, it is asked whether the velocity of point O is equal to the velocity of point A or they are unequal. So in order to calculate this, if I find out the angular momentum about the center of mass of the combined system, then the center of mass of the combined system angular momentum is non-zero in this case. So if this is non-zero, then the velocity of point A is different than the velocity of point O. So this is not equal to the velocity of point O in this case. In the second case, if I find the angular momentum about center of mass, then in this case, if I write the angular momentum about center of mass, then mv into L by 4 minus 3m into v into L by 12. So this comes out to be 0. So it is a case of pure translational motion. So in that case, the velocity of point A is equal to the velocity of point O. In the third entry, if I find out what is the angular momentum about center of mass, is not equal to 0. So in that situation, the velocity of point A and the velocity of point O would be different. So they are unequal. Similarly, in this case, if I find out the angular momentum about center of mass, then it comes out to be non-zero again. So we can say that the velocity of point A is not equal to the velocity of point O. And in the last case, when the center of mass position lie at the point O, if I find out the angular momentum about center of mass, again it is not equal to 0. So we can say that the velocity of point A is not equal to the velocity of point O. So if I do the matching, then the correct matching for D will be Q, and for the remaining matching for C is P, R, S and T. So the correct answer for question number 19, for entry A it is T, for entry B it is PQRS, for entry C it is PRST, and for entry D it is Q. Let's move to question number 20. In question number 20, In the entry shown in column 1, each plate has area A and separation between adjacent plate is D. Here terminal A is connected to positive terminal and terminal B is connected to negative terminal of a battery of EMF V0. Entries in column 2 gives electric field between plates 2 and 3 and also the effective capacitance between A and B. Match the entries in column 1 with the entries in column 2. So let's first of all analyze the given circuits. In the first entry of column 1, it is given that this plate is connected to A, this plate is connected to B, this plate is connected to again A, and this plate is connected to B. So are connected with the terminals A and B. So in the given arrangement, 3 capacitors are in parallel. So the arrangement is like this, and the capacitance value is epsilon 0 A by D of each capacitor. Now this is plate 1, this is plate 2, this is A, this is B, again this is plate 2, this is plate 3, this is plate 3 and this is plate 4. So the C equivalent will be 3 times of C or 3 times epsilon 0 A by D. So we can see that the correct matching will be Q for the capacitance. In the entry 2 of column 1, if I form the circuit, then circuit arrangement will be like this. This is A, one capacitor is this and the other capacitor is this. This is B, this is 1, this is 2, this is 3 and this is 4. So we can see that here the C equivalent will be 2C. So that is 2 times epsilon 0 A by D. So the correct matching for the value of capacitance is P. In entry C, if I form this, in entry C of column 1, if I form the circuit, then this is A, this is B, and here is some let C. So one capacitor is between A and C, so that is 1, this is 2. Another capacitor is between C and B, so that is 2 and 3. Now one capacitor will form between A and B, so this is 4 and this is 3. So C equivalent is equal to, C and C are in series, so C by 2, and that is in parallel with C, so 3C by 2. So the correct matching will be S. And in the case of entry D of column 1, if I form the arrangement, this is A, let this is some C, here it is some B, then one capacitance is between 1 and 2, let this is 1 and this is 2, another capacitor is between 2 and 3, so this is 2 and here it is 3, and last capacitor is between 3 and 4. So this is some 3 and here it is 4. So we can see that this arrangement is not relevant. So the capacitance between A and B is given by this, and C equivalent is equal to C. So the correct matching will be R. So these are the matching for the effective capacitance between A and B. Now we have to find out what is the electric field between plates 2 and 3. So if I find out the electric field between 2 and 3, then the potential difference between plate 2 and 3 here is V0. So the electric field will be V0 by D. In the second arrangement, this is plate 2 and this is plate 3. They are at the same potential. So potential difference is 0. So again, here it is not equal to V0 by 2D. In entry 3, if I find out the potential difference between A and B is V0 and these two capacitors are equal. So the potential difference here is V0 by 2. So the electric field will be V0 by 2 divided by D. So the correct matching will be T, so S and T. And in entry 4, if I find out the potential difference between plate 2 and 3, so here the potential difference is 0. If I find out the electric field between plates 2 and 3 of option D, then we can see here this segment is irrelevant. So the correct matching will be only R. So for question number 20, the correct matching for entry A is Q, for B is P, for entry C it is ST, and for entry D it is R. By this, I wish you all the best for your preparation. Have a good luck. Thank you.